Then there is one last observation or lemma that I'm going to skip the proof here, but we're going to look at it in the exercises. And that is, if you have two disjoint convex objects, then when you look at the extreme directions, you'll see this kind of continuous intervals. In other words, that for the first object could be extreme for a while, then the second object takes over and stays extreme for a while. So you don't have, so basically you have two changes, you know, object 1, object 2, then back to object 1 when you go around all the directions. And this directions means that imagine that you're rotating a line perpendicular to all these directions. So, you know, this, you're rotating this line over here, and you're looking at what is the vertex that is extreme along this direction. And so for a while these red vertices are going to be extreme, and then at some point this takes over and blue gets extreme. And the picture looks like this. And having that, we are now ready to prove one of the main things that we want to prove here, and that is if you have two convex polygons P and Q that are disjoint, so let's say a red one and a blue one, and then you Minkowski sum them with the same convex polygon, so you get P Minkowski sum R and Q Minkowski sum R, then the summations are pseudodisks. And this is relevant because the Minkowski sum of these obstacles, so basically this shows that if you take the Minkowski sum of a bunch of convex obstacles, you get a bunch of pseudodisks. In other words, the complexity of a union will be linear. Okay. To prove this, we just need to show that the interior or this intersection is connected. When you look at the boundary of one object that is inside the other one, it is connected. As we discussed, this is equivalent to objects being pseudodisks. Okay. So how do we prove it? Well, we're going to use basically the previous observation. Imagine that they're not connected. So you have basically one piece and then the second piece. Then we're going to use the previous lemma to get to a contradiction. Okay. So by the observation that we had before, an extreme point of a Minkowski sum is obtained by taking an extreme point of the original polygon plus an extreme vertex or vector of the robot or the polygon R that we're adding to. So for example, for these extreme points, we have to take these extreme points of the blue one, then add the robot, and the same for these ones. You take these extreme points and add the polygon R to get that one. Okay. And now we claim that this implies that when you look at the convex object, the extreme point changes 4 times. So we're going to get to a contradiction. Why is that the case? Because the same thing holds for Q, and now we can subtract R from both of them. Okay. So what happens here is that along this direction we obtain that P, the blue one, is more extreme than Q, because along this direction P plus robot or P plus R was more extreme than Q plus R. So if I look at this direction, we have blue here. Around here we have the Q, or we have, sorry, P. P is extreme. From this we can obtain that P is extreme along this direction. From this we obtain that Q is extreme along this direction by the same argument. Then P is extreme here, and then Q is extreme here. So when we look at all the directions, we'll see that this picture contradicts essentially this observation that we had from earlier. So therefore it follows that these two objects are pseudodisks.